Hi everyone, and welcome to the Big Numbers Study Guide. So this is the first part of Unit 2 where we'll be going over big numbers. Specifically, we're going to talk about a couple different ways of writing big numbers, and then what we'll do is we'll see how we can use them in some of the work we did in Unit 1, and then they'll pop up, of course, as we continue Unit 2 and then just into the future. So first things first, we should start with how we're going to write these numbers. So we're going to deal with big numbers a little bit later in this unit with space. We're going to see it with money now, and then we'll also see it with people. If you're into the sciences, you see big numbers all the time. Chemistry, biology, there's lots and lots of tiny little things, so you're going to see big numbers. We're also going to talk very briefly about very small numbers. We aren't really going to deal with that in this class, but if you are in one of those science fields or you want to go that direction, then you're also going to be dealing with very small numbers. And luckily, this notation we're going to use works really well with small numbers too. It's just a slight change. So definitely go check out the Larson textbook. I've linked it here, but it's also in your reading. They go through some examples, talk a little bit about the two notations, standard or decimal notation, which you'll see includes, with our big numbers, all the zeros and commas. Then there's also this exponential notation. Sometimes you'll hear that called scientific notation. And basically what this does is it hides all the commas and zeros inside, and you can see it right here at the bottom, inside this notation, this times 10 to a power. What this is doing is it's just telling us how many zeros we need. That's really all it is. So what we're going to do is we're going to do a little practice unpacking that, and then hopefully you'll get to see why it's so nice to write it in exponential notation and kind of what we can do with that. So let's just jump into an example. Example 1 here says these are the same numbers. So what number do we have here? Right? There's 1, 2, 3, 4, 5, 6. That means this is 15 million. And I claim that 1.5 times 10 to the 7th, that's also 15 million. So if you go take this and put it into your calculator, you'll see this number. All right? And vice versa, if you get a big enough number and try to type it like this, your calculator may automatically convert into a formula like this. The other thing you'll see with your calculator sometimes, I just want to make a note of this, right? The other thing you'll see is that sometimes it'll say E7. So your calculator might actually say this instead. And the E just stands for exponent. It's just its way of saying 10 to the 7th power. Okay? Some calculators don't have the ability to show you exponents, and so they write E there instead because it would be more difficult for them to show you 10 and then the little 7 that's up here that we all see is raised up. The calculator might not be able to do that, and so that's why it uses E. But it just means the same thing. You see E7, that means 10 to the 7th. So just so you're aware, that might pop up. Okay. So, all right, we've got this notation that I'm claiming is really good. So how do I use it, right? What do I do? Well, this exponential notation, again, the 10 to the 7th hides the zeros and the commas, right? And how we undo this is we just look at that like it's directions. So when I see 10 to the 7th, my brain goes, okay, it's telling me to do something. And so here's what we do. We take our 1.5 times 10 to the 7th, and then what I do is I say, okay, this 7 is what the really important thing is. What this says is move the decimal, and we'll do it together, 7 times, and then we're going to be a little specific here, to the right. Okay, this is very important, and we'll see what happens when we want to move left. So move the decimal 7 times to the right. So I'm going to give myself a little more space here. Okay, so let's just do it. Ready? We got 1.5. Okay, and then you told me, 10 to the 7th, you told me move the decimal place. All right, 1 time. This is 1 move. Okay, and then I want to move it again. This is now my second move. But the problem is, once I've done that, there's the space here. Can't have this space. So what we do is, anytime you want to put a space in, you put a 0. So I'm going to do it again. Now I'm going to go 3 times. put a 0. This is 3. Move it 4 times, 0. 5 times, another 0. 6 moves, put in another 0. And finally, 7 moves, put in a 0. And there's my decimal place hanging out there. And so the number I get overall now is 1, 5, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put your commas in. Remember, the commas go every 3. Every 3 zeros you put a comma. And what do we get? 15 million, which is what we said up here. So just to recap, 7 up here in the exponent says take your decimal, move it 7 times. 1, 2, 3, 4, 5, 6, 7. And we get 15 million. There you go. So that's how you can convert. And how do you convert the other way? That's a really good question you might have. It's like, okay, I've got this big number. How do I make this into my exponential notation? Well, we can go the other way by just saying, okay, find your decimal. Here it is. And now move it until you end up with one single number here to the left. So see how it's 1.5? You'll notice this a lot. You'll notice there's only one whole number to the left of the decimal point. That's our standard kind of way of writing this. If you write it 15 times 10 to the 6th, you could write that, but that's not usually the standard way you see this. You move the decimal until there's only one more spot left to go. So watch. Ready? 1, 2, 3, 4, 5, 6, 7. If I go 7 all the way down, that tells me 1.5 times 10 to the 7th. Okay, so that's the other way. The other way is when you have a big number with all these zeros, you start right at the end, and then you just move the decimal. Count all the way along. You move the decimal. All go, all the way. 1, 2, 3, all the way, until you get right at the end. Right before you would move and have done all of them, you stop right there. So that is the exponential notation. It's just going to take a little bit of practice, but you'll get the hang of it. We won't be using this much, but just so you're aware for some of your other classes, you take science classes especially, you can talk about very tiny numbers the same way. So here's an example. The number 0.000003. Geez, I do not want to write that a bunch of times. So instead, we're going to move the decimal place until we get just a number here, one single number here, and then this will just tell us how many times you moved. That's it. That's how you read this. You have a number, and then this exponent tells you how many times did I move. So watch. Let's start with the 3 times. We'll go this. We'll start with the 3 times 10 to the negative 6. So how does this work? Start with 3. Here's your decimal place. I know it's not there, but remember, a whole number like this, the decimal place is just sitting there to the right. Lazy, we don't write it. Okay, so what do? We start with that decimal point, and then negative 6 means go left. So I'm actually going to give myself a little more space here. So negative 6 means move left. So here's my 3. Here's my decimal. Let's go. 1, 2, I need a 0. 3, give me another 0. 4, don't put a 4 there, put a 0. 5, put a 0. And this said 6, so I do it one more time. 6. There you go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And traditionally, we put a 0 here at the start point. But if you forget that, people know what you mean. But usually, you should put that 0 in there. Done. Take the number that's given before the exponent. Find the decimal point. Right, it's right here. Right here is the decimal. And then move it 6 to the left. Boom, you've got it. Okay, so small numbers, we're not really going to deal with that too much, but just so you're aware, this works both very big and very small. Okay, so that's awesome. So what else can I do to trick you, right? That's always your question. What can I do extra to trick you? Well, there is one other way that you will commonly see big numbers, or a form that you'll commonly see, and especially with money. And so that's these names. So hundreds, thousands, 10,000, 100,000, million, billion, trillion. If you want to, you can check out the other ones. There's names that go much bigger than this. We're not going to really deal with that, but if you're interested, check this link out, and the table keeps going. And so all of these just mean a certain number of zeros. So you see, million means you have 6 zeros. Billion is 9, trillion is 12. For these big ones here, the ones that we're really going to want to focus on using are these three here. And you'll notice that each time you do a new one, it's 3 more zeros. You'll notice me sometimes in videos counting like that, counting by threes. So that's just, we chose to do million, billion, and trillion by those threes. That's it. That's just how we chose it. And it's just because that's how we separate by commas, right? Every 3 we separate a comma. So every 3 gets a special name. Okay, so just be aware of that. Just something to be thinking about. You're going to see that, and we'll do some examples in a little bit where you get to see that. All right, so why, right? Why are we doing this? Well, one very important reason we do this is because when we do calculation with these big numbers, we're often canceling things or just combining them. And when you have 9 zeros in one number, 12 zeros in another number. Think about that. That's a lot of zeros and numbers to be trying to deal with, multiplying, dividing. So instead of messing around with that, we use this exponential notation, which gets rid of the zeros for us to have to think about, and then we can just be a little tricky with our calculation, and we can use some shortcut rules that make our calculations really nice, okay? So here's the thing, though. Big time thing. If you're more comfortable, after we go through this with the exponential notation, if you're more comfortable writing zeros out when you first start trying these problems, write the zeros out. That's okay. It works. It's right. It's fine. You'll notice, though, it takes a lot longer. When you do many problems, it takes more time for you to be writing out these zeros. You'll be more prone to errors, forgetting a zero when you type it into the calculator or write it down. So it's something you got to figure out for yourself. I'm fine with you either way. Exponential notation, standard notation. I may ask you problems which says, please write this out, this number out in both. So you got to be able to know what both mean. But when you're doing problems, stick with what feels comfortable. So let's do an example. And we're going to do it both ways, just so you can see kind of how this looks. Example 3. Remember, this symbol means give this a shot before you look. Just try it out. So what is 8 trillion divided by 2 billion? Again, so we're using these numbers here. And this is another shorthand way to not have to write out all the zeros. So let's do this 2 ways. So standard notation. I've kind of started this off for you. 8 trillion divided by 2 billion. So I wrote it out with all the zeros. And so you could type this into the calculator. That's fine. But there's another tricky way to do this, and this actually is what's going on with the exponential later, which I'll kind of tell you about as we get there. But watch this. Whenever you do this division with this multiplication here, all of these zeros are going to end up canceling out. So watch. 0 with 0. 0 with 0. 0 with 0, 0 with this 0, and just keep going. For every 0 on top and bottom, you can combine them to cancel. And we only stop when we've run out of zeros. Okay. Look at that. I've already messed one up. Let me get rid of that one. Boom. So every one that you cancel has to be connected to another one. So here, here, here. These are all connected together. You can only cancel if there's a connecting one to cancel. All right, so what does that leave us then? Right? What's left? all we have to do is do the calculation with what's left. So after all those zeros have been canceled, this is 8,000 divided by 2. And that's a much easier thing to calculate, right? That's awesome. This leaves us with 4,000. So 8 trillion divided by 2 billion is 4,000. Boom. All right, so there you go. You can cancel all your zeros and you get to something that's much nicer to do the division of. This is fine. This works. Just be careful. You already saw me mess it up once with with trying to cancel the zeros, but this works. All right, what about the exponential notation? So, exponential notation, I've already set it up for you. And this is going to take a little time for you to try to remember, but that's okay. It's fine. You can use the table. Don't forget. I give you this table. Use this table. I say trillion, you think 12 zeros. I say billion, you think 9 zeros. I say trillion, you forget. Just look at the table. Make sure you have this with you. Okay, so what's the kind of neat thing that happens here? Oh, it's so great. Watch this. Whenever you're doing division, multiplication, where you have these exponents here, this times 10 to the power, times 10 to the power, what you get to do is you get to just take the powers and focus on them. And when you do division, when you're doing division here, this turns in to subtraction of exponents. So, what do we end up seeing? We've got 12 on top minus 9 on bottom. That leaves 3 on top. So, what does that look like? How can we rewrite this? 8 times 10 to the 3 over 2, which is really just 8,000 over 2, which is 4,000. Woohoo! So, there you go. What did that do for us? That helped us just like it did with the crossing out the zeros. What did we end up seeing? You took away 9 zeros top and bottom. That's what we did here. 12 minus 9. We took away 9 zeros. Because remember, the 10 to the power is just telling us how many zeros. So when you see 2 times 10 to the 9, you should say a 2 with 9 zeros. This is, I mean this literally. This you can read with as 2 with 9 zeros. I should probably spell zeros correctly. And then this one would be 8 with 12 zeros. Oh man, you know what I'm talking about. You know zeros. Come on. There we go. So then I got 12 on top, 9 on bottom. Subtract, I'm left with 3. There you go. This also works with multiplication too. So for multiplication, we have to be a little careful here. With multiplication, this is where the power really comes in using this form. Multiplication, that turns into addition of exponents. So watch this. Let me give you a problem, and we'll see kind of, if you try in standard form, how terrible it might be to try to do. So how about 3 billion times 2 million? Okay, so if you wanted to do this in standard form, right? If you wanted to do this in standard form, you would do 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Did I do it right? Hundreds, thousands, millions, billions. Got it. Times 1, 2, 3, 1, 2, 3. Look at that. I don't want to multiply those. Look at all those zeros. What do I even do? But, so again, this is your standard form. If instead we use the exponential form, this becomes 3 times 10 to the 9th times 2 times 10 to the 6th. And what we get to do, pretty neat idea, is we get to just say, how do I multiply these? All I do is I take this, and I add them. What's that going to give me? It's going to give me 3 times 2, I still have to do those, times 10 to the 15th. Boom. Look how quick that was. No zeros, no messing around with that. You check this in your calculator to make sure it works, but boom, boom. So the multiplication is super quick when you do it the exponent way. So let me just write that out, that this was the exponential form. All right. So again, standard form, all good. You could just throw that into the calculator with all those zeros. Exponential form, a little bit easier to do by hand. And just as a heads up, the calculator is most likely, no matter which form you do this in, going to give you the answer in an exponential form. So just be ready for that. All right. So if you want to see more of these rules that I'm talking about here, dividing these exponents is subtraction, multiplication is addition. If you want to play with those rules a little bit more, you can check that out at this link. Of course, ask me questions too. Okay, so then we also, now that we have these big numbers, we can do everything from Unit 1. So what does that look like? And we're going to do more of these as we go. So this isn't all of the things we can do, just 2 examples. First one, example 4. 350 billion is what percent of 1 trillion? We did this, right? A number is what percent of another number. And we did this a couple different ways. So whatever you're comfortable with, you do that way. That's fine. My way to set this up is what percent of 1 trillion? I know that that should be on the right-hand side of my little equation. Of, remember, means times. So that's that little piece there. And I need to find the percent, this p in my equation. So I divided both sides by 1 trillion. This is just what we did last time, right? And now, what do I do, right? How do I do this? Well, you have one option, which is to use your standard form. Totally fine. Totally okay to use your standard form here. That's fine. I wrote out all of these. This is 350 billion. This is 1 trillion. And I just canceled all the zeros. Right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros top. So I canceled them on the bottom. And I'm left with 35 over 100. Which we know that that's 0.35 or 35%. Ta-da! 350 billion is 35% of 1 trillion. Same thing we did in Unit 1. It's just we got big numbers now, and we have to be a little careful with how we do the calculation with them. But the setup and the execution, the algebra, all the same. Okay? All right. Well, so we could do all those percentages, percent increase, percent decrease, all that stuff. We also can deal with units and rates. And so these problems are just like the unit problems that we did in Unit 1. Sorry, I'm saying the word unit a lot. But now we have really big numbers we're dealing with. So here's an example. The U.S. national debt is approximately $28 trillion. There are about 328 million people in the U.S. If we divided the debt up to every person, so I'm taking the $28 trillion, of course this is not realistic and not something we would do, just to get the numbers in our head. If we took that debt and we said, okay, all the people in the U.S. are going to pay an equal share of that debt, how much would each person owe? So how do we attack this problem? It's a rate problem, right? So we have to ask ourselves, right at the beginning, what do I know? What are my knowns? Well, I know $28 trillion. Again, remember, we're focusing on the units here. And I also know 328 million people. Okay, another unit. Well, what do I want? What am I trying to get at? Go back to the problem. What do I want? I want to know how much would each person pay? Oh, what does that mean? I'm thinking pay, oh yeah, that's money, dollars. So I'm looking for dollars, okay? But then it's not just dollars, it's dollars, can you go back through? Each person, dollars per person. Or if you still want to use the word people, same idea. So what do? I want dollars per person. I have dollars. I also have persons or people. I just have to combine these. And you combine them in the way that gets you the units you want. So, dollars on top, people on bottom. Let's do it. Dollars on top, people on bottom. There we go. Right here, do these units check out with what we want? They do. Dollars on top, people, persons on bottom. Awesome. So then how do we solve this problem? Just do the numbers. Forget about the units now that we've checked they work. Just focus on the numbers. Over 328 million. All right. And again, you could write out all the zeros here if you want to and just check, cancel them and go. That's fine. Or what you can do is you can write it in exponential notation. So I'll do the exponential this time. 28 times 10 to the 12, because there's 12 zeros in a trillion, over 328 times 10 to the 6th. Okay, because there's 6 zeros in million. Okay, so then what do? Well, we can then do our work with canceling these extra zeros packed into these 12s and 6s. So remember, I'm looking at this now right here, and I'm saying, okay, that's 12 zeros on top minus 6 zeros on bottom. Okay, that leaves 28 times 10 to the 6th, over 328. And that's way easier to handle, right? This is way easier for us to handle. Much easier to put in a calculator. From here, you can just throw this into a calculator if you want. So get out your calculator and see what this looks like. So this would be, and you can plug it in so many different ways, right? If you're comfortable, you could say, oh yeah, this is just 28 million over 328. Or you can type it in as the exponent, either way, times 10 to the 6th divided by 328, which equals $85,365. We'll round to just the dollar. Boom. So what does this say? To pay off the national debt, if we broke it up to every single person in the U.S. paid the same amount, each person would owe $85,000 approximately. There you go. So you'll see there's lots of ways to do this calculation. You want to put zeros in, go for it. You want to try this exponential notation, go for it. Doesn't matter to me. Do what works best for you. And I'm happy to help you out in any case. So we're going to be doing more with this, right? The unit is bigger than this. We've got the geometry section, some space, and all these things will kind of play together. But the things that you have to really focus on here, let me scroll up, are just getting these two forms, your commas, your exponential notation, right? And again, even if you prefer this notation, your calculator is most likely going to give you answers in this notation. So you've got to make sure you practice going back and forth between them. There's computer exercise problems to get you to practice this, and then you can also see the first written homework as well, just to kind of see what kind of questions I'm going to be asking. So go ahead, get to work, and then ask me if you have any questions. Don't forget, you can stop by office hours or schedule an appointment to visit on Zoom outside of that.